If it's 0, we basically put it as red. If it's not 0, then we put it as green. And this is where we basically use the attributes, boundaries, and area. Then we copy the rest of that there. And you must be able to get this result. Once you have that, then let's use that patch function that we talked about. And what this patch function is just a visualization. So you get boundaries, you give it the basically vectors and where those boundaries are, and it would show you with a patch of basically a particular color. And then we color it based on which one has an ID of covered and which one doesn't have an ID of covered. So let's do bounds, which basically is the boundary of that particular one. I'll just go back here. Let's go to the bounds here of 2. That means that the second surface here, and 1, the first, and then the second, and then the third, basically each column. And then B here, which is the comma B at the end, represents the surface color. So if you put G, that means green. If you put R, that means red. If you put C, I think it's cyan. So these types of things. So if you put B, is blue. And then when you utilize that and you put it as green, just enter it. Then once you enter it and go back and take a look at it, basically this is how it's going to look. You're going to have a green patch representing that particular surface that has been considered as covered. And this is for the second one. Now, basically, I'm going to do this as a for loop for each and every one of these. That's what I'm going to do. For j equal to 1 to PO, which is the number of rows that we have considered. If ID underline covered of j is larger than 0, that means that we found the correspondence. Then we make that patch into green. So we put patch, which is a bounds IL of j. You can, again, use the ID underline covered of j as well. It doesn't really matter in that sense. The problem is if you use ID underline covered of j, the problem becomes that the zeros also need to be considered there as well, and you don't have an element of zeros. That's why I had to call IL underline IL of j, and we put it as green. Else means if this is 0, you basically copy the exact same function and you paste it as red. You just change that last one to R. Enter, end, and then end. And then what you're going to get is something like this, where those surfaces are green. And then if you take a look at it, the other surfaces that were not covered are actually considered as red. And this is how you can find which surfaces of a particular object is actually going to be considered or not. After this, what we need to do is to find, okay, in a generic sense, how would we be able to find a particular objects with respect to how much of that object as a whole is covered. We're going to talk about that after we just copy this in that function. And the cool thing about this in this function is that every time that you're going to go through it, because the patch function basically adds to it itself, it holds it, you're going to get that addition every time that you're actually going through this whole function. And then at the end, because if you're running this function, you're not going to have the point cloud. You have to just add it as a view free or an axis equal. So you have to do those types of things as well. I'm going to show how it is. And we can also find how we can put point colors to points in order to export it into Cloud Compare, just to see how a particular point is colored and how a set of points are actually going to be the same or representing the same surface, essentially. Use a cell array to introduce points that would be considered in a particular surface, and we just add it and give it a particular ID, or give it a particular color, and all of them same color basically. Use something like this to create a set of points of scans instead of the BIM, because we want to now export it into Cloud Compare. And I'm not going to go with the export process here with you, because you can just write it into a text file and then import it into Cloud Compare. But here I wanted to kind of show you that you can create a cell array of a set of points that is from the x_scan R for the ID of surf, and then this would be the first 3 columns of that, and then the last 3 you just represent colors, so that you can, if for this particular set of points that is belonging to this surface, only these have a unique color to them, so that you can compare them, you can see which one is which. So these would be the points that would be considered as points that are covered. So you can put it as green, and all of these points would be green. That means that all of these points have a correspondence, and that correspondence has shown that there's a coverage that is met. 9 scan points to a particular surface in the BIM. And for those points, we basically identified with a particular color. We just copy this, just change the variable name as covered to assigned. And instead of the 0, 255, 0, because this is RGB, right? Just put rand of 1 and 3. And if you want to do it in Cloud Compare, you have 2 options really. Sometimes if you upload it in or a particular point cloud, it gives you whether the color numbers are between 0 and 1 or between 0 and 255. MATLAB typically only has it in 0 and 1. You can change it as well. But it doesn't matter if you put it as rand of 1 and 3 or you put it 255 times rand of 1 or 3. Rand of 1 and 3 means it gives you random numbers between 0 and 1, and that would represent a particular surface color by means of the R, G, and the B. And every color can be mixed together by these randomized levels of R, G, and B to give you a nice unique color. So for this, because we have this, the reason why these types of things happen, you see these red, is because it's always in good practice to allocate the sizes of the matrices and vectors early on, especially for for loops. We know the basic size of that. That would be really good for computational purposes. So this is going to be a cell vector of PON1. The second one is also going to be a cell vector of PON1. Okay. I put an else here as well because I wouldn't mind doing the red as well for the ones that don't have the coverage. So I just go 255. R, G is 0 now, and then B, and then end. And again, you could put just 1 here if you upload it into Cloud Compare as zeros and ones. That's no problem either. So let's paste this, do that. And you don't necessarily need to upload it in Cloud Compare. You can also visualize it here. Just, you know, I just set it for the sake of it. And you can see for the cover, the first one had a RGB, meaning the R was complete. The second one had a G that was complete. And then the assigned is completely random values that have been assigned to it. Let's PC show scan points, underline assigned of, let's say, 2 and 1 of the first 3 and then the second 3. Just copy the first part. And instead of 1 to 3, you now put 4 to 6. Okay. You typically want to, because it's from 0 to 1, it would identify it properly. If it were to be, let's say, something else, it would have created problems. So typically in MATLAB, the original one is that. And here, just as a side note, you can see a lot of these points that belong to the surface are basically being considered. This is one of the problems of scan versus BIM in this way. That's why in the next sessions, I'm going to talk to you about the curvature-based method, which I've utilized quite a bit. And when we add that to this, it just gives, it just makes this into an actual plane rather than, all of these points that just randomly and arbitrarily were selected by means of that distance threshold. And the good thing about that is that it kind of reduces the dependency on the distance threshold, because if you increase the distance threshold, this is just going to be increased like this, right? But we only need the points that belong to that particular plane for that. So that was just a side note to understand that we have still some more work left to do. Let's hold this and let's just go J. Actually, we just have to put J equal 1, and then we basically do that. So it's going to give us an error here. It's going to go that. So you have to just put J equal 1, and then, or you just change J there, put that, and then just can add the next part there, each and every one of them, and so on and so forth.